So far, we've seen examples of ions that act as acids or bases or both. However, some ions don't hydrolyze or react with water at all. Examples include conjugates of strong acids or bases. For example, the chloride ion will not alter the pH of the solution. Metal cations that do not form strong bonds to water will also not hydrolyze water. These include the transition metal cations that have a +1 charge, like copper+. Copper+ will not cause a solution to be acidic. Main group metal cations with a +1 or +2 charge, like either sodium ions or calcium ions, will also not affect the pH of the solution. Therefore, a solution of sodium chloride, for example, is expected to be neutral because neither the sodium ion or the chloride ion will hydrolyze or react with water. Let's summarize the steps to take to determine whether a solution containing ions from salts will be acidic, basic, or neutral. First, write down all the major species present and evaluate their acid-base character. You will need to be able to recognize common weak acids and bases from the tables that we've presented. In the previous sodium carbonate example, there was only one ion that could hydrolyze water. The carbonate made the solution basic. What if there is more than one ion that reacts with water? In this case, the species with the largest K value will dominate. For example, a solution of iron 3 fluoride will contain both iron 3 cations and fluoride anions. The iron 3 cation is expected to act as an acid because it will form bonds to water, but the fluoride ion is expected to act as a base because it's the conjugate base of hydrogen fluoride. Which one wins? It turns out that the species with the larger K value will dominate. In this case, the Ka of iron 3+ is larger than the Kb of fluoride, so the solution will be acidic overall. It can also happen that a given ion is amphoteric. In other words, it can act as either an acid or a base. What do we do then? If a species is amphoteric, the reaction with the larger K value will dominate. For example, the species hydrogen phosphate is amphoteric. If we look at the K values, the Kb is larger than the Ka, so the solution is expected to be basic overall. Make sure that you're able to calculate Kb values from the correct Ka values. Take a moment to convince yourself that the Kb value of the HPO4 2- ion shown is the correct one. Let's try an example. Will a solution of calcium nitrite be acidic, basic, or neutral? The first question to ask yourself is what ions will be present in the solution. In a solution of calcium nitrite, we will have both calcium ions and nitrite ions present. Then ask, for example, is calcium ion expected to react with water? The calcium ion is not expected to react with water because although it is a main group metal cation, the charge is only 2+, and it needs to be greater than 2+ for it to react with water. So the calcium ion will not affect the pH of the solution. Next, consider the nitrite ion. Nitrite is a weak base, and therefore this is expected to affect the pH of the solution. What is the result for the whole solution? The calcium did not affect it, but the nitrite was a base, so the solution is expected to be basic overall. In this presentation, we've shown how to determine whether a salt solution will be acidic, basic, or neutral by evaluating the acid-base character of the ions involved.